Thanks. My dear participants, now I am going to talk about graphics, base graphics. Actually, there are mainly three graphics. One is base graphics, which were developed by Robert Gentleman. Then his student Dipayan Sarkar developed a very good graphic software, and that is known as Lattice, that is for multivariate data analysis. And latest development is ggplot2, which is due to Haley Wickham, a great contributor towards the development of R and data science. So Haley Wickham's ggplot2 is the latest fashion, and once I was going through a book on introductory statistics with Python published by Springer. So author writes in the preface of the book that R is better than Python because R has ggplot2. So it is just, but I am not going to talk here ggplot2, that I will talk later. Today I am going to talk about base graphics, some base graphics, and that is hist, plot and curve, histogram. See, here we have created a data x is equal to 12, 15, 13, 20 and then 14, 16, 10, 10, 8, 15, and then we want a histogram. The function is hist. Suppose control 2, if I write hist of x, what it returns? It returns frequency here on y-axis. It returns frequency here on y-axis and not the density estimates. So what we do to make the density estimates? We have to you have to write prob is equal to true. Prob is equal to true means on y-axis it will return probability density estimates. So here these are the graphics. So here we are getting the graphics, and this is here it is density, not frequency. And there is advantage of using this prob is equal to true, because it returns density estimate, so we can add up density. This is a plot known as histogram. It is evident from the figure that data is small, even we have a nice histogram. Now I would like to talk about plotting characters with colors. There are many options of plotting character, and there are many options of the colors also, because how many colors are there in R? We can have colors and see 657 colors options are there. So, and every color option has a number like 657, and the color is yellow green. 655 the color is yellow 3, and 656 the color is yellow 4, like that. So there is a very good option of colors, and similarly there are many plotting character, like you can use plotting character as star, as filled circle, as open circle. So here I am going to show a plot which shows in which on x-axis it is 1:20, on y-axis 1:20, and then plotting character, each point is shown by a different plotting character 1:20, and each point is different, is shape is shown in a different color 1:20, and then CEX, character expansion, is 1.5. So character expansion, if it is actually 1 is the normal, so 1.5 times bigger than the normal. So when we run this chunk, we are getting this figure. We are getting this figure. So here number one plotting character is open circle, and here this is the one. Second plotting character is a triangle. Third plotting character is plus. Fourth plotting character is multiplication. Then this hexagon. Then this different sign. Then all these are there. All these are there. Plotting character 20 is like this. So, and character expansion, it is 1.5 times bigger than the normal. If suppose we change, instead of 1.5, suppose we are using plotting character, instead of 1.5, 2. So it will be twice to the normal. See, here it is twice to the normal. Here 1.5 times bigger, here twice to the normal. So this way you can change this plotting character. In the above figure, we must have read, we must have tried to explain 20 plotting characters options with 20 color option. Moreover, character expansion CEX is equal to 1.5 stands for the character expansion 1.5 times that of normal. Now I would like to describe the function plot. Actually, there is a concept of high level graphic function and low level graphic function in R. High level graphic functions always create a new plot, whereas the low level graphic function add on existing plot. So here hist is a high level graphic function because it generates a new plot. Similarly, plot is also a high level graphic function because it creates a new plot. So here x is equal to sec 1:10, y is equal to x raised power 2 minus 10 into x, and plot y versus x. So these are the things which I am going to. So here we have got the figure. So we have got the figure. So this is the curve. On x-axis it is 1:10. So that means it is a sequence of 1, 2, 3 up to 10. And on y-axis it is x raised power 2 minus 10 into x. So it is somewhat quadratic curve. And plot y tilde x. Plot y tilde x. And we can have one more option, and that is, here it is plot y versus x, or plot x comma y. It will also return the same plot. It will also return the same plot. So these are the options. But here we have many other options too. For example, plot y tilde x, comma, and here we want type is equal to L, type is equal to B, or type is equal to O is open circles, B, type B. See, it returns both, B stands for both points and lines. So here it is like this. But if we have another option, plot y tilde x and type is equal to, it will be small o, then see what kind of picture it comes. Here it is penetrating, small o gives option penetrating inside the circle, and then if we have plot y tilde x and type is equal to, say for example, h, see what you get. It is like this, vertical bars. And similarly, if we have plot y tilde x and type is equal to not h, not o, not b. Suppose we want small s, so it will return step functions. See, this is the step function. Capital small s. So all these options are there with this plot. Now I would like to briefly describe the curve. Here the function is curve. I can go for control 2, args plot, and if we, so here there are many options, and args curve. So these are the options. Function, expression, first argument is expression. From is equal to the lower bound, 2 is equal to the upper bound, n is equal to 100 points, add is equal to false, and type is equal to L, x name is equal to x lab name is equal to x name, and then y lab is equal to null, and log is equal to null, x lim. So these are the options, and we can have help about curve. So where it is located? It is located in curve is a function of graphics package, and draw a curve corresponding to a function over the interval from 2. Curve can plot also an expression in the variable x name and default x. So these are the expressions, these are the arguments, x lim, y lim, and these are the details of, and these are the certain examples. Now I am going to talk about curve. Expression is what? Expression here is x raised power 2, and from lower range is -2 and upper range is +2. So here I have plotted a curve, a parabola in the range of minus 2 to plus 2. Similarly, if we want to plot sine curve. So, expression is equal to sine, from is equal to 0, 2 is equal to 6 pi. So, here this is the sine curve which we are getting. This is the sine curve we are getting. And then suppose we can have changes in the range. Say for example, control 2. Suppose we want use cursor key to go to the previous command. Here from is equal to minus 6 into pi. Pi stands for pi, and see, it is better that I should type here so that this window will be used. Curve expr is equal to sine expr is equal to sine, and from is equal to minus 6 pi 6 into pi and 2 is equal to 6 into pi. So, if we will run this, this is the sine curve we are getting. It is in the range of 6 pi to minus 6 pi to the plus 6 pi, and this is the curve, sine curve. Suppose we want to plot a function, say for example normal distribution. So, we shall talk in detail about the distribution, but here to compute the density, the function is d norm. So, d norm and argument here must be x. You don't write that argument that matters, because with curve there must be argument x. You cannot put any other argument. And from is equal to minus 3 to 3. It is normally said that most of the area under normal curve, they come under minus 3 to plus 3 range. So, curve, see, this is the normal distribution curve with minus 3 to plus 3. Suppose we want to change the range from minus 4 to plus 4, minus 4 to plus 4, and see what result you are getting. You are getting this result now. So, we can make these changes. Now, suppose you want to plot a function which is not defined in R. So, first you have to define the function. Plot function f1x is equal to 2x plus 3x raised power 2, and in the range of minus 3 to plus 3. So, first we have to define the function f1 is equal to function of x 2 into x plus 3 into x square. Now, we can plot this function curve, and the first argument is function f. We can keep here f1 inside that x also, and from is equal to minus 3, 2 is equal to 3, and LWD, line width is 3 and color is equal to blue. So, color option is also there. See, here we have got this function. Suppose we write here curve curve. Instead of f1, just we can write f1 its argument, and from is equal to minus 3 and 2 is equal to 3 and color is equal to say red, and say for example LWD line width, not 3, rather say 2. So what you will get? See, this is the line. So here we have reduced LWD line width from 3 to 2, and we have gave a color option that is red, and here you can write f1 and its argument, but it must be x. If you will put some other argument, it will not plot. Say for example, if I write, either you leave this, just write, say for example, if I write y or something else, something say x1, then it will not run. It is showing error. It must be, so it should not be anything other than x. For curve, it is always x, and then it will run. It is running. The function is plotted into the range of -3 to +3. Output is reported in the figure. So here these figures will be generated into the document, but here I am not going to talk about those things. Documentation part, when I will talk, I will do all those things, and we can ref figure also. Histogram, say for example, if you define some other function, you can plot that. For example, suppose you define a function f2 is equal to function of x, and expression is 3 into x raised power 3 plus 3 into x square, again a polynomial, 3 into x square plus twice into x plus some constant, say for example 6. So we have defined the function. The function has been successfully defined, and if we want to plot this function in the range of -3 to +3, so we will have to write curve f2x. Either you can write f2 just or f2x, and then from is equal to -3 and 2 is equal to 3 and col is equal to say blue and then LWD is equal to 3, and close this. Unexpected symbol, in the curve f2x. Oh, in the definition of f2x there is some mistake. f2x curve, yes, here f1 comma from is equal to 3 in the definition of f2x. 3 f2x is equal to function f 3 into x raised power 3 plus 3 into x raised power 2. There is nothing seems to be wrong. 3 into x raised power 3 plus 3 into x raised power 2 plus twice x plus 6. So it should run here bracket, extra bracket is raising the problem. Now it will plot. Spelling blue is wrong. BLUE, blue. Now it will run. So it has run. So this is the graph of the function, that is fx is equal to f1 fx is equal to 3 into x raised power 3 plus 3 into x square plus twice x plus 6, and this is the plot of the function. So this is the plot of the function. So this way you can define any function and you can get the result. So now I shall continue in these things, on these things graphics, in the next lecture tomorrow.